Okay, so let's have a look at number 2. We have been given essentially f of x equals 3x minus 5 all over x plus 1. And in part A, we've been asked to work out the inverse of f of x. Now, the way I tend to do that is to say y equals 3x minus 5 over x plus 1 and make x the subject. So in order to make x a subject, I'm going to say y multiplied by x plus 1 here equals 3x minus 5. I expand the brackets, xy plus y equals 3x minus 5. And if I want to make x a subject, I want all the x's on one side, everything else on the other. So I'm going to do xy minus 3x equals minus 5 minus y. And now I have to factorize the x out. So we get y minus 3 equals minus 5 minus y. And therefore we get x equals minus 5 minus y over y minus 3. Or alternatively, if you made x the subject, you also could have had 5 plus y over 3 minus y as well. If you took, at this stage, if you took the one I'm ticking, if I took the x's over to the right hand side and y's over to the left hand side, I would have got that. So either answer. But our final step is to actually say the inverse of f of x. At this stage, all we have to do now is replace the x's with y and the y's with x's and the x with f minus 1 of x. So 5 plus x over 3 minus x is our inverse. Let's have a look at part B. So in this question, we've been asked to work out fg of 2. So what I'm going to do first is to work out g of 2. And we've been given g of x. G of x is x squared minus 3x. So g of 2, if our input is now 2, our output is going to become 2 squared minus 3 times by 2, which is 4 minus 6, which is minus 2. And so now I need to work out f of minus 2. And again, we've been given f of x. So I'm going to use my input as being minus 2. 3 times by minus 2, minus 5, all over minus 2 plus 1. So we get minus 6 minus 5 over minus 1, which is minus 11 over minus 1, which is 11. So there's our answer for part B. Now, next part, we've been asked to work out the range of G. So I'm just going to write, essentially I'm going to write g of x equals x squared minus 3x. We have been given a domain, and the domain is x can be any real value as long as x lies between 0 and 5 inclusive. So what I'm going to do to work out the range, it's generally a good idea to sketch it, sketch the function. So I'm going to sketch g. Now this is a quadratic, very simple to sketch. Actually, we need one more thing, and I'm going to come to that in a second. So if I factorize this, x minus 3, we know the roots are 0 and 3. So I'm going to draw a quadratic that goes through 0 and 3. Now, due to the symmetric nature of this curve, we know that the x-coordinate of your minimum is going to be 1.5. And if you wanted to work out the y, we could substitute that back into the equation of the curve and get our y value. So y equals 1.5 squared minus 3 times by 1.5, which is 2.25 minus 4.5. That's one way of doing it. We can do a number of different ways. We could, of course, have, so I'm getting minus 9 over 4, which is minus 2.25. Okay, so this is minus 2.25. Oops. We could have completed the square, we could have used differentiation. All of those ultimately would have helped us get to the same answer. Now, this curve is only valid between x values of 0 and 5. So essentially what I need to do is discard everything before 0 and actually extend up to 5. Let's just say 5 is over here somewhere. And we need the y value at that point there as well. So if the equation of the curve is x squared minus 3x, I'm going to get g of 5 equals 5 squared minus 3 times by 5. 25 minus 15 is 10. So this value here is 10. And we can ignore anything after 5. So now looking at that graph is going to help us work out the range. The range is essentially the allowable heights or the allowable y values of this graph. The lowest y value on this graph is down here, and the highest y value is up here. Now this y value down at the bottom was minus 2.25. This y value up here is 10. So we can then say that g of x is greater than or equal to minus 2.25 and less than or equal to 10. Okay. Now, let's move on to part D. The question is, explain why the function g does not have an inverse. Only one-to-one functions have an inverse, and g of x is not a one-to-one function. So if we look at the graph, there are multiple x values that have the same y value. For example, if I pick this and I pick this, they would both have the same y value. And that means it is not a one-to-one function. A one-to-one function would have been a function where each x value has one y value and each y value only has one x value. And that's not the case over here. And you can only have inverses. The inverse function only exists for one-to-one graphs or one-to-one functions.